Please encourage me to create new videos. Please like, share and subscribe to my YouTube channel. Thanks for watching. In this video, we are going to look at what is race condition in Java multithreading. In Java, race condition means getting the unexpected output or the program not behaving correctly as per the expectation. Race conditions can arise when multiple threads are running at the same time and are accessing the shared resources or shared objects without any proper thread safety or synchronization mechanism. This is because multiple threads may interfere with each other's operations on the shared resources or shared objects, leading to the unpredictable results. This is just a code preview of race condition. I am going to run the program having 4 threads and you can see the output of the final count. Expected count is 40,000, but it will be different all the times when we run the program. I am going to explain the race condition with the help of simple code example. This is just the shared counter object that will be shared by multiple threads as shown below. These are the 4 threads that will be operating on the shared counter object. This is just a code snippet of example which we are going to run. In our example, we have 4 threads, thread 1, thread 2, thread 3 and thread 4 that are incrementing the shared counter object at the same time without any proper thread safety or synchronization mechanism. Each thread is expected to increase the counter by 10,000. Final value of the shared counter object should be 40,000, which is the expected sum of increments of all the 4 threads. Due to lack of synchronization mechanism, the final count might not be 40,000. The expected result will be different at all the times. This is because one thread might read the value of counter object, then another thread may modify it before the first thread writes its updated value back. This execution of multiple threads in unorganized manner lead to race condition or unpredictable results. To fix this race condition, we can use various thread safety or synchronization mechanisms that we will be discussing separately in the coming videos. High-level steps for creating race condition code example are: Step 1. Create the counter class. Counter class contain one class level variable, or we can say instance variable named count. We will be incrementing count variable with the help of increment method. And for retrieving value of count variable, we will use getCount method. Count variable will be updated by multiple threads at the same time, and it is the main candidate for the race condition. This is the corresponding code of step 1. We have counter class and we are going to create the object of this counter class, and this object will be shared by 4 threads. This is the count instance variable and it is the main candidate for race condition. This instance variable will be updated by multiple threads. This is the increment method that will be called by multiple threads to update the value of count instance variable. In this line, we will get the name of currently running thread assigned by the JVM. In this line, we will be incrementing the value of count instance variable. By using the getCount method, we will be retrieving the current value of count instance variable. Step 2. Define the task. Create the counter task that implements the runnable interface. This counter task accepts the counter class object in its constructor. We will be incrementing a counter class variable, or we can say instance variable named count. Each thread will increment the value of count variable by 10,000 in counter task. This is the corresponding code of step 2. We have created counter task class that implements the runnable interface. This class defines the task that will be performed on the counter class object. This is the counter class reference variable. This is the constructor of counter task class that accepts counter class object. This is the definition of run method that contains logic for incrementing the counter object. We are incrementing the counter object by calling the increment method. All the 4 threads in our example will be updating the shared counter object. When we start the 4 threads, the control will go to the run method. Step 3. Starting the threads and passing the counter task as the argument. Create the 4 threads and pass the counter task as the argument to these 4 threads. This counter task further contains the counter object as an argument. All the 4 threads will be operating on the shared counter object. Wait for all the 4 threads to complete and check the final output of count instance variable. This is the main class where we are going to create the counter class object that will be shared by 4 threads. I will explain each line of code step by step. This is the counter class object that will be shared by 4 threads. We have created 4 threads and passed the counter task as an argument to these 4 threads. Each counter task contains the shared counter object. Here we are starting all the 4 threads by calling the start method on each thread. Here we are waiting for all the 4 threads to complete by using the join method. Join method causes the program to wait until thread on which it is called completes its execution before proceeding to next line of code. This block of code will catch any exception that occurs while executing the above lines of code. It will display the final count of shared counter object that contains count instance variable. The value of count instance variable is different all the times when we run the program. I am running the program and you can see the output. I will be running the program multiple times and you can see different value of count instance variable that will be changing with each run. Expected value of count instance variable is 40,000, but we will be getting different values due to race condition. This race condition has arisen due to multiple threads accessing the count instance variable in unorganized manner. For better understanding, please download the source code from GitHub repository. I have provided the link in the description section of this video. Please encourage me to create new videos. Please like, share and subscribe to my YouTube channel. Thanks for watching.